So today I'm gonna show you, as you probably know already from the title, all the things that are basic functionalities in AWS. And to do this, we are actually gonna use Localstack. So you don't need to set up any credit card, any AWS account. You can just use your local. I did already an introduction video about Localstack that I'm going to leave a link in the description below for you. However, in this video I'm going to go through all the basics, so even if you didn't watch that video, keep going through it, and maybe if you miss something or you don't understand why something in a certain way, maybe go back to that video so that you get a better understanding of what's going on. So this is what we're going to show today. We're going to see how we can create an S3 bucket directly from the console in our Localstack instance. The second thing is going to create a static website from a bucket. So we're going to host a static website in the bucket that we created in here, and we're gonna show what it looks like. The next step, we're going to create a table in DynamoDB hosted in your local in Localstack. We're going to see how to insert and retrieve items doing a scan operation. In the second section of the video, probably this is going to be a 2-video section, I'm going to talk to you about CDK. In the CDK, we're going to create a Lambda function, which is going to be able to, initially we're going to make a Lambda function that works within CDK, and then we're going to get data to and from DynamoDB. Then we're going to set up the API gateway so that we can actually call this Lambda function from the static website we created on the first step. And finally, we're going to display data in the static website that we created. All of this with a serverless architecture. So if you guys are ready, I'm gonna start showing you. So the first thing we're gonna see today, we need of course to have Docker running, and we need to have our Localstack instance running. So what I'm gonna do, I'm going to show you what is my current Localstack instance, what it looks like. So let's create inside our project a folder where we're going to put the Localstack configuration. So let's create a folder called Localstack. And inside we're going to insert the docker compose.yaml file. Now the contents of this file, you can find them in the documentation of Localstack itself, and you can find more information about it in my previous video, which I'm going to have a link in the description below. Let's remove this bit because it's about the web UI, which we don't need. And let's have a look at the services. We need to have serverless for things like S3, DynamoDB, etc., which are the basic services, and make sure that there is CloudFormation so that when we go to the second part of the video, everything you have is nice and set up. Other things you need to make sure is, for example, to have the Lambda executor set to Docker, the host temp folder to tempdir, and the volumes are mounted below so that any change you do is going to be persistent within your Localstack instance and not going to be thrown away every time you restart Docker. However, deleting this folder is going to make it really easy to restart from scratch. Alright, so now let's open up our console and let's run the Docker Compose app, which is going to instantiate Docker with the Localstack so that we can actually start working. Once Docker is up and running, we can actually run the first command. We can run the command mb, which is make bucket, and we need to specify the endpoint URL to localhost 4566. I could use actually another tool called AWS Local, which is provided by the same guys from Localstack. However, I'm not gonna use this. I'm gonna do everything within using all the flags from AWS so that you guys get a good idea what is happening. So I'm gonna specify which region I want my bucket in. So in this case, the default one is US East 1. And finally, I'm gonna give the bucket a unique name, prepended by the prefix S3 : //. So let's gonna give it something like static S3 bucket, something very simple, and the bucket has been created. Alright, so let's move on to the next command. The next bit to do is to provide this bucket with the proper permissions. First of all, we need to block the URL from the bucket from being accessible and writable from the outside. So we want to block all of those points, and you do this through the public access block configuration. And this string comes just from the documentation in AWS. If you want more details about it, leave a comment below, and happy to answer what each one of these flags means. However, for brevity, I just prefer to go quickly through this presentation because it's gonna be quite long anyway. Okay, so let's move on to the next bit. What we want to give now is to give the public access for read of the URL, so that if you do a get on the bucket, you can actually read the contents of the bucket, which is what allows it to be a static website. So we're gonna set the policy with the statement of effect allow on get object on the resource bucket S3 bucket. Alright. And now the last bit, we need to provide which are the pages that we want to provide in case of index and error. I'm going to set both to index.html. Alright, let's run the command, which is AWS S3 endpoint URL, and then we specify that we want to have a website on the bucket name, and then we set the index document index.html and error document index.html. So now we wanted to display a website. So what I'm gonna do, I downloaded a free template from a website, and I'm just gonna copy it inside this folder. And then I'm going to sync this database, the website template together with our S3 bucket, so that we can actually run it well. So the command to run this one is to use the sync. So like always, we set the endpoint URL to localhost 4566 followed by sync, and then we're going to specify syncing which part. So we want to display the current location / website, followed by our bucket. And this is going to upload the contents of the website folder into our S3 bucket. The S3 bucket is going to be S3 :/S3 static S3 bucket, and now we have our website visible. Let's quickly try if a curl request to the bucket actually works. So curl http localhost 4566 and followed by the static S3 bucket /index.html. So we're going to request this file, and as you can see, it's available in here. Let's open up our browser and let's have a look if it looks okay. And as you can see, our beautiful website is actually working with all of the JavaScript that we can use. So we just discovered how to create a bucket from the console and how to serve a website from the bucket which has been created in the console. So now let's go on and let's discuss the other methods, which is we are going to create a table in DynamoDB. We are going to insert items in the DynamoDB table. Finally, we're going to have the scan of the table. Ensure that in the services of your Docker Compose, of course, we have serverless, or this example won't work. Well, you can also have DynamoDB displayed. Also, throughout this tutorial, we need to have a look, before we move on to CDK, I'm actually gonna display you something about IAM roles, because they are important to understand once we move on to CDK, why CDK actually makes things easier. So let's start by creating a folder for our second section, which is about DynamoDB. And I'm gonna create a folder DynamoDB, and then followed by create another folder 01, create table. And in this table, we're gonna put JSON, which is the table definition. So table-definition.json. If you wanna have more information about this table definition, there is a video I made a couple of weeks ago, about a simple CRUD app in DynamoDB. In this case, I'm gonna use something very simple, which you can find in the Amazon documentation, where I have a table which has artist and song title, where the artist is the partition key and the song title is the sort key. Sorry, artist is partition key and song title sort key. Okay, now that we have this one, we need to go back in our console and use this table definition to call the DynamoDB API from our console and create the table. As always, we're gonna put our endpoint URL, then we follow by DynamoDB create table, and we specify the input file, the CLI input JSON file, which is gonna be file colon table dash definition.json. Run the command and now should be created. So the next thing to do is to retrieve the tables that we have and make sure that this table name music is actually present in our DynamoDB instance. To do it, we can simply run the scan command on the table music, which should return no items. So DynamoDB scan table name music, and as you can see, is returning no items. Alright, so the next bit will be to insert some items. Let's insert a couple of records. For brevity, I've already defined a JSON file with that matches this table definition. And to keep things clean, I'm going to create another folder to actually insert all those items. So insert items, and now we're gonna create a file items.json, and inside here we're gonna put we're gonna do a batch insert of items. So I'm gonna do a two put requests, in which I'm gonna put an item where the artist is Queen, song title Radio Gaga, and another item where I use Lady Gaga and the song title is The Queen. Okay, so let's move on and let's move to this folder, insert items, and let's run the DynamoDB table that is going to do this put insert. Now the command is DynamoDB, always on the endpoint localhost 4566, DynamoDB, and then batch write items, and then we are going to specify the request items, which is essentially the file items we've just created. So file items.json, and now all the items have been processed. So if we run the scan once more, we should get 2 items, where we have the 2 items we just defined, and this table has now 2 records. So that was pretty easy, wasn't it? If you guys found anything of this hard to understand, maybe let me know in the comments below. I'll be happy to make a new video where I'm gonna go more in detail about any of those operations. Going back to our outline, we made these 3, and we also did a scan. Now in theory I should go to CDK, but as I mentioned before, I want to give a little bit more introductions around the fact that I want to explain the IAM roles and how they work, because this is what really makes the difference once you go to CDK and you don't actually have to worry so much about the roles, because the roles are going to be automatically created for you, which is one of the features of CDK. So I'm gonna talk about IAM roles, and then I'm gonna call a little bit about a very plain Lambda function, and we're gonna do a little bit more in CDK to complete this tutorial. So let's go on and let's start with Lambda functions and IAM roles. Of course, first we need to do IAM roles. So I'm gonna create a new folder which is 03 IAM roles. So I create a file called execute_role.json, and in this file I'm gonna put the JSON to get the permission for an execution role. This role, what it's gonna have, is going to have the permission to write and execute Lambda function. And I'm just gonna skip where I'm typing, just because for brevity. Okay, so magic of video editing. As you can see, the DynamoDB permissions have been created. We can do logs, and we can use STS for providing the roles. And now the second part of this file, I'm gonna add the principal service, which is a Lambda Amazon AWS.com, and I'm gonna provide all the resources with a star. Again, all of this stuff, it's usually managed when you use in AWS console. All of those items are done for you. So you can actually go and check, and when you actually create permissions, those JSON files are created for you. We're gonna need a second file, which is gonna be our trust policy, and this one is going to allow the assume role for Amazon AWS. Alright, so now that we are set up with the roles that we need, we're gonna simply create those two roles. Then we're gonna create a Lambda, and we're gonna provide the Lambda with this role. So the endpoint to call in the AWS command line is IAM create role, and then provide the role name, which is in this case AWS Localstack YouTube tutorial role. Then we need to provide the assume role policy document, which is equivalent to the file execute role.json. Execution role.json. We execute, and the role has been added, as you can see. Let's do the same thing for our trust policy. Of course, we need to have a different name, or the previous one will be overwritten. Okay, so let's have a look at all the roles that we have available, that we should have created in our local stack. Of course, there are more than just the last two I created, because I've been testing those scripts and I use them for work as well. So there you go, we have our roles, and now we can actually go on and create a function, a Lambda function, which is the last bit of our tutorial, or the first part at least, before we move to CDK. So let's create our Lambda functions with the correct roles that we've just created. So we're going to create a new folder where I'm going to put the Lambda, and then we're going to split into, we're going to create an index.js file, and I'm going to keep this example extremely simple. It's just going to be a simple handler where I'm going to console.log something, and then I'm going to call it. That's it. Nothing more I want to do, because I want to keep this really, really simple. So we need to have an exports.handler, which is a function, exports with an S. Okay, so a Lambda function takes three parameters, which are event, context, and callback. And we can actually console.log one of these. The event might contain, for example, the path. But in this case, I'm simply doing a console log, and I'm going to write the console log data. That's everything. Okay. So now let's go back to the command line, and let's give this function, let's deploy this function, and let's give it permissions to run. So I created a function .zip file, which contains our zip, our index.js file only. And what I'm going to do now, I'm going to deploy the function using a function name. So the syntax is lambda, and then create function. The function name is going to be YouTube lambda function. And now we need to provide the zip file, which is going to be a file B, because it's going to be now a binary file. So file B : function.zip. And then we're going to provide the handler, which is index.handler, because it's the file name is index and the function export is handler. And lastly, we need to provide the runtime, which is Node.js 12.x, so we can set 14, for example. And now the role. By the way, all of this, we're going to see that once we start using CDK, all of that is going to be done for us, okay? here and just simply copy and paste the role name that I generated before, because I don't want to make mistakes. Like sometimes happens that you think you remember the role name, but actually you do it wrong. Okay, so we created the function, and now all we have to do is to invoke the function. So instead of create function, we're gonna run invoke function. Invoke, and the function name is everything the same. Remove the these two dashes, and then we're gonna say output.json is where the output of our function, if n, is gonna go. So we run it. As you can see, the function run, but we haven't seen anything. And of course there were no output because this function doesn't do any output. And the console log did not show up. Why is that? Well, because we need to actually specify to the invoke function that we want to have a log. We want to have a log type of type tail, and we want to query the log result, which is one of the permissions we provided before. We want to output the text encoding from a base64. And there you go. We just created all the parameters of the request ID, which version, and this data is our console.log coming from our index.js. The info is the type of logging, of course. Okay, so let's move on to CDK. So I'm going to use for this example TypeScript. So let's get started with the necessary installs. I'm gonna move myself to the AWS Localstack, and then we need to install a few items. npm install in the global AWS CDK local and AWS CDK. I already have those ones installed, so it's gonna take just a few moments to set up. Now, if you follow the video until now, you know that Localstack, we set it up with Serverless, SNS, CloudFormation, and the reason for this is exactly because I want to go through CDK. So now that we installed the tools that we need in our local, we can actually create, let's make a dir, let's call it CDK YouTube tutorial, CDK YouTube tutorial, and here we can do a CDK local init sample app language TypeScript. Calling this function and scaffolding everything for TypeScript in our project. So it's gonna create a number of commands, and as you can see, we have 3 commands in particular, which is a deploy, which is the one that we're going to use when we want to deploy the stack to AWS. In our case, it's going to be deployed in Localstack. Diff, to check what are the differences between the currently deployed stack in our Localstack and the current state of our source code. And the last one is the synth, which essentially makes the CloudFormation template that you can save, for example, in a file for a repository. In the meantime, the CDK YouTube tutorial has been created, as you can see, and here let's have a look at which files have been created as a consequence of this init command. So we created this file, CDK YouTube tutorial stack, and what is gonna do this one? This one essentially is the class that is going to wire up everything together. This one is actually, you can see that the different configs have been inserted into here. This is called from the bin directory and initializes the new app that we are creating. Now, to make sure that everything is gonna work, of course, you know that TypeScript doesn't actually work on Node.js directly. So what do we need to run? We need to run npm run watch, and this is going to watch our files for any modifications, and it's going to create, now we're going to see in a second, that is going to create our JavaScript files, which are the ones that are actually going to be executed in our Lambda functions. Okay, so let's go ahead and let's modify this file in here. So, and also you need to open a second terminal, simply because the first one needs to keep running, or you can put it in the background if you wanted to. So we have let's have an exploration of the current stack. We can do CDK local synth, and we can see it's because I'm not inside the correct folder. So if we run the synth command, we're gonna see what our stack currently looks like. And we're gonna have all of the resources needed created for us in this YAML configuration file. So what you can do, you can actually say out.yml, and this is something that you could actually use for your own use, to commit into Git, so that you know what's going on at each part of the configuration. You can see that there are a few places, such as we can go through it just quickly, just follow the different types that we have. So we're gonna have AWS SQS queue, which is, well, it's our queue. Queue policy is the IAM policy for SQS, so that you can actually send the messages to and from the queue. Then we have the subscription, that is a subscription that of course is gonna be between the queue and the topics. The topic, which is again is the topic. The metadata for the stack, and well, I came back to the beginning. So these are the policies that have been created by default. So now, which command do we need to run now to execute the bootstrap of all of this environment? So what does it mean to bootstrap the environment? To bootstrap the environment, it means that we are going to execute and build all of this inside a bucket. So what you can run is CDK local bootstrap .sh, and this is going to use the AWS 00000 for our local stack. And now that everything has been bootstrapped, we can actually run CDK local deploy. And now it's going to tell us, if you look at the terminal, it's going to tell us, oh, we're actually making a deployment which is going to change, which is going to make some changes, blah, blah, blah. So what we need to do, we need to say, are you happy with those changes? Well, I am, so yes. And I'm going to deploy the stack. So what can we do now? Now, normally in AWS, you can actually access the console and have a look at the CloudFormation stacks. However, we are not using we are not using AWS, we are using Localstack, so we need to use the console for this. So what can we do? We can do AWS, CloudFormation, and then list stacks, endpoint URL 4566, and this is gonna tell us that we have a YouTube tutorial stack just deployed. Alright, so now the next bit is to look at the details of this stack that we have just deployed. So let's have a look at CDK YT tutorial stack. And what can we do? We can actually run another command which is going to tell us the resources of the stack that we just deployed. So the command I'm running is list stack resources, and then we need to specify which one is the stack name, and finally the endpoint URL to still be our local stack. So let's run this command and let's have a look at what's happening. We have all the stacks that have been created right now. So we have the metadata, we have the queue, we have the topic, and the subscription. Okay, so what would you like to do now? Now we saw how to do this quick introduction about deploying this stack. However, it doesn't really do anything right now. So I wanted to get to the point in which we have a Lambda function. I'm gonna call a Lambda function from the stack. So we want to create something a bit different than this boilerplate. So I'm gonna remove all of this. Okay, and now we can actually introduce, since we remove this file, we can actually have a first look at what happens if I run now the CDK local diff, since we already deployed. So now it's going to check what's in the remote and what's in the local. CDK local diff is going to say, well, this is what's happening. So now what we want to do, we want to install a library for use of AWS Lambda inside the project. So we're going to install AWS Lambda. And now we can actually use import star as Lambda from AWS Lambda. And what we can do, we can also keep things nice. So we could actually write the function directly to here. However, maybe we can actually make a Lambda and then index, no, hello.js. So inside here we're gonna do exactly what we did before. Export.handler is an async exports. It's an async function that takes the same parameters as before. We're gonna just take the exactly like we did in here. We can have a function. Just copy this one, as I never remember what's the order of the arguments. So we can return an event, status code 200, and then body we're gonna put hello from CDK. Maybe we can put some headers. Content type alright, so now we need to call this hello function, hello from Lambda CDK. So now we need to call this Lambda function from inside here. So as you might remember, when I was running the Lambda function in here, I was specifying a runtime, I was specifying the handler, etc. However, right now I am not specifying any handler. Alright, what I'm doing, I'm saying, well, you use, I'm gonna use this Lambda, and I'm gonna say I have a function, and in this function I'm gonna specify the runtime, which one is my handler, and where to find the code, which is what we did before. But before we were like making a zip file, specifying the handler, and saying use Node.js 14. Here we're gonna do the exact same. So we have const hello, which is a new lambda.function, and then we specify this for the scope of the class, and then we're gonna give a name, my function, and finally we're gonna specify the runtime, which is lambda.runtime.node.js. is actually gonna specify the different ones. The handler, like before, is gonna be hello.handler, and then the code, we can find the lambda.code from asset, and then we need to put the full path. In this case, it's gonna be lib lambda. And now we should actually be able to run the CDK local diff, and this one is telling me that I have a new function which needs to have a service role, and it's gonna have a basic Lambda execution role. All of this done just through CDK. We didn't actually have to understand all the different policy permissions as we were doing before. Okay, so what we're gonna do now? Now we're gonna do, we did our diff, we are happy, so we can do a cdn CDK local, and now we can run the deploy command. It's gonna say to us, well, this is exactly the same as before. We have our diff, we are happy, yes, let's deploy. And we just created our function. Okay, so let's have a look at which functions we have now available. We just created this YouTube Lambda function, which is our function name. Hello.handler. Actually, this is the one that we just created with the CDK. This is the function we just created, so let's take the code, and now we're going to invoke this function. Okay, so I'm going to paste the command in here. So we are invoking the Lambda function, and we want to be raw with base64 out. This one is the function name, which we just grabbed. It's a request response type of function. We are giving a response. In fact, we have a request and a response. There is no sign requested. There is in this function that I saved, I have a payload. But the which I'm going to provide. We don't have to specify the payload for this example actually. And then the endpoint, as usual, it's our local host. So the function executed, and we should have now an output.json, hello from CDK. Now that file that you saw me calling, it's because I was simulating what this hello function could look like. However, I need to modify the function to show it. So what I'm gonna do, hello from Lambda from CDK, actually I'm gonna modify this one, and I'm going to put the JSON.stringify event null 2, so that we can have a nicely formatted event. And I'm gonna take this file, this API Gateway proxy file. So let's create this API Gateway AWS proxy.json. By the way, if you are wondering where these things are coming from, they are simply from you can get them from the AWS console or from the documentation. It's simply a test method that we can use to call simulating a proxy call. So now our body has this event. So now when we call this function, now that I'm gonna call this function, I'm gonna do a Lambda invoke. However, I'm now going to specify this API Gateway AWS proxy. Status code 800. Okay, of course I need to deploy. CDK deploy is gonna show me that I made a change on the function. And let's invoke the function. And as you can see now, my body is going to contain the contents of that file. And there you go. So now it's missing one bit. Now we cannot call the function, of course, directly. We need to do the last bit. We need to install the API gateway so that we can actually call the function from our local website we set up at the very beginning. Alright, so what do we need to install for this? We need to install the AWS Gateway library. So let's install AWS API Gateway, which is at AWS CDK API Gateway. So now we installed this API Gateway, and we're gonna add an import star as API gateway from API Gateway. And now what we want to do, we want to essentially handle the API Gateway with an endpoint, specifying that we want to run this hello function through it. So we can do a new API Gateway dot lambda REST API. So it means it's going to build and handle REST API for us. Now we're going to specify an ID. So before was my function, we're going to do my endpoint. And now we need to specify the handler, which is going to be hello, we defined just above. And once more, all we have to do, we're gonna do a new deployment. It's gonna tell us, well, now you have a API gateway. Let's have a look. There is an error. Okay, okay. Now should be alright. It's going to create the stack. Okay, so now here we get this URL. However, as you can see, it's not a localhost valid file. All right. So what does it mean? It means that we cannot really execute this API through this URL, which is HTTPS. Is on localhost and does these subdomains. It doesn't exist in our local. What exists in our local is, and I'm gonna write it just above here so that you can actually see, HTTP localhost 4566 slash is gonna be the ID, which is this number here. Actually, it's gonna be REST APIs slash ID, and then execute API, and then user request with the underscores, and this is what should be our response if we do a curl. Okay, so I debugged what was happening. Essentially, what was happening is that the URL was wrong. I need to put a prod section, and then I can actually provide everything else was the same. So it's going to be localhost 4566, REST APIs, the ID of the API that has been outputted from the command, then prod, user request, and then a parameter. So user request. And now we can actually execute inside Localstack with all the different items. And now we can actually say hello from Lambda CDK. And well, at this point, if you go back to our outline, doesn't miss anything else, but to go back to our website, open our JavaScript file, and to add, we can add a simple fetch. And as you can see, I've already done it. So now what can we do? We can go, we can redeploy our S3 bucket by doing a sync of the folder path. So we can go cd ... Now we have our website in there, so we can do AWS S3 and sync it. And now we can open the browser, we can open the console, and we got a 500 error. Let me have a look. I'm not sure why I'm getting this. However, we actually get our response with our body, with our headers, with our URL, and we can actually display the data. So anyway, that's everything for today's videos. I hope you guys enjoyed, and as I said at the beginning of the video, if you stick until the end, I will have a surprise, and the surprise is I'm actually going to create a repository in which I'm going to put some files with all the scripts that I've used throughout this tutorial. And the reason is that you can actually go through and have a look at everything I've done by running those scripts one by one. If you guys enjoyed this video, please leave a thumbs up, and if you're interested in this subject, please let me know in the comments below. If you have any questions, please subscribe, because I really do these videos with passion, and I hope to see you guys in the next one. Thank you, bye bye.